In this lesson, we're going to review solving a system of equations algebraically. So, we're going to use algebra to solve for one of the variables, and then after we know one of the variables, we'll solve for the other. But the problem is we have two equations, and there's two variables in both equations. So we can't find the value of one variable right off the bat. Instead, we have to somehow combine these into an equation that only has one variable. So what we're going to do here is we see y equals x plus 1 and y equals 2x minus 1. We're going to take this value of y, because y equals 2x minus 1, and substitute it into this y. Okay, so the first thing we're going to do is rewrite this now. So instead of it being just y equals x plus 1, we have that y is the same as 2x minus 1. So we have 2x minus 1 equals x plus 1. So we take from one equation the value of y in terms of x and substitute it into the y in the other equation. So we get an equation with just x's. This method is called substitution. So at this point we have one equation, only one variable in it, so we can solve for x. We have 2x minus 1 equals x plus 1. The first thing I want to do is get all the x's on one side. So I'm just going to subtract x from this side, and then also from this side. So we have 2x minus x. This would be 1x. We still have the minus 1 equals 1. So now, isolate x, we have to add 1 to both sides, and we end up with x equals 2. But just the x value alone isn't the solution. We also need to know what the y value is. So we just take any of the equations, let's try the other one, y equals 2x minus 1, and plug the 2 in for x. So y equals 2 times 2 minus 1, y equals 4 minus 1, y equals 3. So our solution is 2, 3. X is 2, y is 3. In order to check this, we found that y equals 3 when x is 2 using this second equation. So now we're just going to plug these values in and see if it works for the first equation. So we have y equals x plus 1. Okay, we have that y is supposed to be 3 when x is 2. So we have 3 equals 2 plus 1, so 3 equals 3. And that checks out. So here we have how to solve a system of equations algebraically using substitution. We just solve for one of the variables in terms of the other. In this case, it was already solved. We have y equals 2x minus 1, and we plug it in to this value of y. So here's an example of a system of equations where one of them is already solved for y and the other isn't. This is already solved for y, so let's just take this and plug this in to this y. So we have y plus x equals 6, but now 3x minus 2 is the same as y. So we have 3x minus 2 plus x, so this part just represents the y. We still have the plus x equals 6. Okay, combine like terms. 3x plus x is 4x minus 2 equals 6. Now we'll isolate the x, so we add 2 to both sides. On the left we just have 4x, and on the right 8. Now divide by 4, and we get that x equals 2. Now just plug this into one of the equations and solve for y. Let's use the top equation. So x is 2, so we have y equals 3 times 2 minus 2. Y equals 6 minus 2, so y equals 4. So our solution would be 2, 4. And since we use the top equation to solve for x, we use the bottom equation to check it. So y plus x has equals 6. Y is 4 plus x, which is 2, equals 6. And we have that 6 equals 6, so it checks out. This is our answer. So we just plugged in 3x minus 2 for y because according to the first equation, this is the same as y. And we plug this into the y in the second equation. We ended up with an equation with just x's. We solved for x. Then using that x value, we solve for y. And of course, we check it. In this example, we have another system of equations. 5x minus y equals 9. 3x plus 2 equals 8. And neither one of these is solved for a variable. So what we're going to do is we're going to solve for one of the variables in one of the equations and then use that to substitute into the other. To me it looks like solving for y in the top equation would be the easiest. Just put a box here so we know this is our system. So to solve for y, let's subtract the 5x. Okay, note that this is still going to be negative y here. And we have 9 minus 5x. Okay, but we don't want to solve for negative y, we want to solve for y. So we have to divide by negative 1 to get rid of the negative sign. And we divide each of these by negative 1 also. So you get y equals negative 9 plus 5x. So now we solve for y, and we solve for y in the top equation, so we're going to plug this in to the second equation. So I'll rewrite the second equation. 3x plus 2y equals 8. Let's plug this in for y, so we still have 3x plus 2, and it's 2 times y, so it's going to be 2 times this entire thing. Negative 9 plus 5x equals 8. So y is negative 9 plus 5x, so let's plug this in and we'll use parentheses. So remember to distribute this 2 because the whole thing has to be multiplied by 2. Okay, let's just simplify this side first. So 3x plus 2 times negative 9. So let's change this plus sign to a minus sign. So just minus 18. 2 times 5 is 10x. 2 times 5x is 10x equals 8. Okay, now we'll combine like terms. 3x and 10x is 13x. Minus 18 equals 8. So let's add 18 to both sides. So we have 13x equals 26. Divide by 13. And x equals 2. Now I'll just plug this into one of these to solve for y. So let's use the top equation. We have 5 times 2 minus y equals 9. 10 minus y equals 9. Minus 10 minus 10. Negative y equals negative 1. So negative y equals negative 1. Divide them both by negative 1 to get positive y, and we find out that y equals 1. So our solution is 2, 1. So this one is probably the most difficult type of system of equations because we have to solve for one of the variables first. In this case, we solve for y in the top equation. We found it to be negative 9 plus 5x. Then we substituted this into the second equation. So 3x plus 2y equals 8 became 3x plus 2y times negative 9 plus 5x equals 8. We solve for x. Then using this x value, we solved for y, which is 1. And our solution, of course, was 2, 1.